All right, so let me start off with just a little scenario of like what development might look like and why we're really kind of what sparked the idea for us building this framework. So let's say you are, let's see if I can get this working. So you're building a web application. It's a very simple application, really. Let's see here if I can get this working. There we go. All right, so you're building an application, very simple stuff. You have everything here on the left-hand side is in Java. So you have a little person object, and you've built a little Spring Boot REST controller, just returning a list of those people. And then on your client side, you're essentially mapping over those and returning a little template. All is well, all is good. But then 2 weeks later, Bob comes along. Now, Bob is working pretty late on a Friday, and he's really hoping to get out with his friends, but he just needs to do a couple of quick things. And this data model that we have is just kind of slowing him down. He doesn't really need the whole separate first name and last name. He just wants to display a name and whatever. So he figures like he'll kind of simplify things a little bit for himself and just kind of have a single name string here instead. And obviously he fixes his code, but he didn't know that we're also depending on that in an entirely different place in the code base. So he fixes his code. He kind of looks around in the office on Slack, nobody's working. So he's like, well, I might as well push that to production and just go out and have a couple of beers with my friends. Has a really good time and wakes up the next morning with 8 messages from his boss saying that he broke everything along with his headache. So this is not an ideal situation. So when we have a larger code base, this is a very typical situation where we don't necessarily kind of know what's happening or kind of who is depending on the data that we're providing from the backend. So if we make a change to our data model, say, it's easy for us to kind of know where we're using that, but we know might not be available, kind of or we might not know who else depends on that. So when we're working with Java, we're very used to kind of the safety net that we have from compile time type checking. We have this little safety net that tells us like when we break something, it'll tell us like, well, actually you need to go and fix that file and that file too, because you made a change. And it would have been really, really kind of handy if we had that same feature here. But usually when we expose something through REST, we kind of lose that type safety. So we essentially have 2 apps talking over an untype safe communication channel. So that's really where Hilla comes in. So what we've created is a front-end framework that specifically targets Java backends. And because we know that both the front end and the back end are using a type safe language, we're able to really optimize the way that we do things and simplify a lot of things by doing type generation and just providing that safety net of type safety all the way from the back end to the front end. So really what a Hilla app is a Spring Boot backend, a TypeScript front end using the Lit framework from Google. It'd be interesting to know if anyone's used it here. I'm going to kind of show how it works hands-on in just a couple of minutes. But if you have used it or you haven't used it, let me know in the chat and I'll kind of take that into consideration during the live coding portion here. And then we take these standard kind of libraries that are out there that are kind of well understood. And then we add a little bit of magic to make them work even better together. And that's how we kind of created Hilla. Now, we built this specifically for creating these rich interactive applications. So it's not really something that we created for building, say, a website that's has a couple of dynamic parts, but we really are trying to help people build these more complex, dynamic, meaningful applications and really optimizing for making that more complex task easy. To do that, we have a pretty large library of UI components that we ship with. And this is, if you've ever used the Vaadin framework from before, this is the same set of components, just exposed as web components. So we have a big library of the kind of building blocks that you need to build an application. And then, like I said, we do this automatic type conversion from Java to TypeScript. So whenever you expose a service from the backend, not only are you gonna kind of get a way of calling the server, but it's also going to make sure that whenever you call it, you will get kind of full type information, and that will help us kind of keep the front end and the back end of our application in sync at all times. We also utilize the same thing for sharing validations across server and client. So if you define validations on a kind of Java object on the server, you can use those same validations in your UI form, and then the framework's going to revalidate those on the way back. So again, making sure that things work the way you would expect. We also wanted to kind of reduce some of the hassle with building a full stack application. Namely, you usually have to start a backend server, a front end server, and kind of make sure that whenever you make changes in either one, you want to kind of reload the application to see the latest. So with Vaadin, with Hilla, you only have one build script that starts the entire application, both front end and back end. And regardless of where you make a change, you will always kind of get the browser reloaded automatically for you. So it's a very kind of quick way of seeing what's happening as you're typing. We also just recently added a new feature for reactive endpoints. So if you're using reactive data types like Flux, you are able to expose those and kind of consume data as it's coming in. So that's pretty cool if you're building something where you have an event-driven backend, you have things happening, and you somehow want to just kind of reflect those in the UI as things happen. All right, so that's a lot of talk, and I promised code. So let's hop into our IDE here. And can we get a confirmation that everyone's able to see the font here? Are you guys
Not yet, Marcus. No.
okay? Let me see here what's going on.
No worries.
There we go. There we go.
Brilliant.
All right.
Hello, world.
Well, there were a bunch of slides here too, that we completely missed. So this is what we were building, and then Bob came along. He removed name, went for a beer, woke up, things blew up. Anyway, there was a whole set of slides. Apparently, I forgot to share my screen. I just recently, yesterday, came back from Europe, so I might be a little jet lagged. I apologize. I'm glad that we caught that before I started live coding for a bunch of kind of time here.
Well, and
So
you just caught us up on Bob's whirlwind pub crawl, so we're good.
good. All right. So I mean, this is really the meat of it. Like, this is where we were going to spend our time, and like all of that was fun, but this is kind of the meaningful stuff. So all right. So like I said, we have a unified build tooling for this framework. So by just running Maven in our Spring Boot application, the default Spring Boot target will just start up this application. And let's see here, that should get us a hello world. All right, so first of all, I didn't catch if people had used lit or not. So I'm gonna walk us through kind of the basics of basic building blocks. And now we're right now in TypeScript land, so bear with me a little bit. So this here is our view. A view is essentially just a TypeScript class that extends from view. It has a render method that defines a template, and then it has this custom element annotation or decorator, as they're called in TypeScript land, defining what the tag name should be. So if we look at what's running in the browser here, we can see that we have a HTML tag here with the same name. So we're essentially, when we're using lit, the concept is very similar to React in that we have this component-driven design, but we're working with browser technologies, which means that we're defining DOM elements, essentially HTML elements that the browser understands. And like I said, if we make a change in our code wherever, the browser will get reloaded. And the way Lit works is that it's a reactive framework, meaning that it has a component has a state and this template. Whenever the state changes, the template will always automatically get updated. So to show you how that works, let's define a property called name and just initialize that to an empty string. And we can then replace this world here with a name. So we'll say this dot name. And essentially, if we don't have a name, we could also just default to world like this. So nothing should change here. And if we put in something for name, so if I put in my name here, you'll see that that updates here. But of course, what's kind of more interesting is that since we are working with just HTML elements here, we can set these properties like we would on any HTML tag. So if I defined the name here as an attribute, I say, hello, San Francisco, you will see that that gets reflected in the DOM right away. And likewise, if I do that programmatically, so if I do $0, which is a shorthand for accessing the selected element here, and I say name is equal to Marcus like this, you'll see that that gets updated as well. So that's the basic idea of just this component model using Lit. So we're using TypeScript, we have a reactive template and properties. Now, the way this works then when we're building a view is that in our view, we can update the state, which will then, again, trigger this re-render. So if we wanted to dynamically change this name, we could create an input. What's going on here? Input like that. And for this input, we can say that the value is equal to this dot name. And then on the input event, we can run a piece of code. So in this case, we're going to say that when we get an event, we're going to set this dot name equal to the event's target value like that. So essentially the value of this input field. And if things work out here, I can type in something here and you can see that that's getting automatically reflected in the DOM as I'm typing. Now, as I was saying and didn't show you in the slides because I wasn't sharing my screen, is that Hilla comes with this big library of UI components that you can use to build your application. And by having this rich set of UI components, you can spend less time trying to build accessible, kind of good-looking mobile-friendly UIs. You can take these ready-made UI components and create it faster. So we can change this regular input into a Vaadin text field like this. And the web component spec requires us to close the tag, so we'll do that. And the text field behaves kind of like an input, but it has more features. So we could give it a label, for instance, name, so people know what to put in there. We can say it should have a clear button. So if I type in, I can clear out the input like this. So it's a kind of an input, but more feature rich. All right, but let's jump into the actual what makes Hilla specific or kind of different from other ways of building an application. So if we open up our project here and just look at what the project structure looks like, you can see that we are in a Spring Boot project. So we're kind of extending from Spring Boot here. We have a couple of dependencies to the Hilla Spring Boot starter, and then I've added a in-memory H2 database here. So a very kind of straightforward, plain Spring Boot project. Here in the Java sources, I have defined a little backend. So essentially I have a person entity and the person entity, I've defined a couple of validations so that we can see how this shared validation structure works. So for instance, first name and last name can't be empty. An email needs to be a valid email. And then if we look at the other part of the equation here, you'll see that there's a front end folder here. And in here, you can find the front end of this application. So source main Java, that's where the backend of the application lives, and the front end is where the front end lives. And that's where we can find this Hilla view. You'll find other stuff like routing, where we're defining how these views match it, kind of map up to different paths and so on. So if we now want to access our backend, so if we want to expose a endpoint in the backend so that we can access some of these person entities that I've created a little data generator. So we have a little set of data that we can work with. The way we go about accessing the backend is by creating an endpoint. So I'm going to call this person endpoint.java like this. And the way I turn a class into an endpoint is by adding an endpoint annotation like this. So not entirely different from like creating a REST controller. I also need to define access control for it. So in this case, I'm going to say anonymous allowed. I'm not going to start defining a security setup, but that's pretty straightforward, just plain Spring security essentially. In this case, we're going to say that everyone is able to access this. We're going to create a constructor here, and we're going to inject or auto wire this person repository that I have here for accessing the JPA. Here we go. So it's a JPA repository for accessing that in-memory H2 database. Call this repo because typing repository is pretty difficult when you're doing it live. And I'm going to assign this to a new field like this. All right, so now we have access essentially to our database from here. And the first method that I want to expose to our client is just to find all. So just return everything that we have. So this will be a public list of person objects like this. We'll call this find all. And this will return the repo.findAll. So we just essentially delegate to this person repository. Now I'm going to close the sidebar here and go back into my front end here. And what I want to do now that we have this reactive component model is that I need to define a state that keeps track of those people, and then I can use them in my template here. So for this, I'm going to use a state. The difference between a property and a state is that property is something that we expect somebody from the outside to be able to set the way that we did here in the dev tools by setting the attribute, whereas state is something that's internal to this component. So for state, we're going to call this people, and the type of people will be a person array like this. And we're going to initialize that to an empty array. Now, what's interesting here is that I was able to just import person here, even though I haven't created that. So if we go into this and look at what we have, you'll see that it's a TypeScript interface that matches the Java object that we had. And that's something that was generated for us by Hilla. So if we were to make a change to our Java object, that would automatically get reflected here in the UI. Now, the next thing I want to do is call the backend. So I'm going to override the connected callback lifecycle function of a view. And that's something that's in the HTML spec. So whenever this view gets added to the DOM, this callback gets called, and that way we can call the server. So I'm going to do an async function called connected callback. And this will first of all called super.connected callback. So we initialize the top level view, and then after that we can do other stuff. So in this case, we're going to say that this dot people, let's see, people is equal to await person endpoint dot find all. All right, so a couple of things to note here. First of all, if you're not familiar with async await, this is a way of dealing with asynchronous code in a non-blocking way. So this would be similar to using promises or completable futures and adding a listener saying like, once this completes, then do that, but just in a slightly more readable way. So even though this looks sort of like synchronous code, it doesn't block the UI thread. So it's a very performant way of doing this. The other interesting thing here is that we were able to call our backend as if it were a TypeScript method that just exists. And we can see that the types here match. So we are getting back a array of person objects the way that we would expect. Now, when we want to use these, let's just look at a basic use case. So we can create an unordered list here, and we could just say this dot people.map. So we could map over each person and return a new template for each person. And here we could do a list item and say p.email, maybe like that. And we would see all the emails here. Now, like I said, we have this big library of UI components, so let's use those instead. So I'm going to use a Vaadin grid for this, and I'm going to define 3 columns on it. So I'm going to create.
Marcus, did we lose you?
Who? Did you lose me?
Is any?
Can you hear me? Can you hear me? Uh-oh. Can you hear me?
Yes.
Okay.
So you can hear audio?
Yeah, looking at the chat, looks like everyone can hear you.
Okay. So maybe it was, did you hear me throughout the thing, or did it break for a while, or what's happening here? Can somebody just confirm that you're?
No, yeah, you, I think I could hear you. I think Peter broke up a little bit, but yeah, and I'm looking in the chat. No, went well. No breaks with you. All good.
Okay, so might have been just Peter breaking
Yeah,
up then.
I think so.
I could definitely hear his audio breaking up when when he was asking for it.
Yep.
All right, so assuming then that everyone saw what I've been coding so far, what I'm doing is I am creating a grid with 3 columns, and what I want to do then is take this array of people and map them to these columns. So I'm going to define a path that's equal to the, first of all, first name, last name, and email. And then I'm just going to pass in this array here as the items of this array, or sorry, on this grid. So this dot people. And with that, we now have a data grid showing all these people. And I also want to show kind of, if you haven't kind of been working with a reactive UI before, this logic might always seem a little weird. So I'm just going to show a couple of examples of kind of how that works. So if we wanted to use this name input here to filter down the people, what we could do is define a getter, say filter. Okay, let me try that again. Filtered people. And this would then create a regular expression, first of all, to kind of capture the name here. So post is equal to a new regular expression. And we're just going to use the name, which is what people are typing in, and we're going to make it case insensitive. And then we can return this dot people dot filter. So we're going to filter over them, and we're going to see if the concatenation of first name and last name. So we're just going to create essentially a string with the first name and the last name and see if that matches this regular expression that we have. And then we're going to return this updated list. And if we then change this from, instead of using the source array, to using this getter, so we're going to use filtered people here instead, what we can do is type in a name and it will filter down that list as we're typing. Cool. So it might take a little while to kind of figure out, well, how do I express myself in a reactive way? How do I not imperatively say, like, whenever somebody types in, go and update the list, but just define a function that is able to do that on the fly. All right, so then let's take a look at the next step here. So how do we go about selecting a person and updating or kind of editing them so that we could save them back to the server, make sure that those validations actually work the way that I promised earlier. So let's first of all build a little form. So for that, I'm going to use some of the built-in CSS helper classes that we have. So I'm going to create a grid with 2 columns, and it's going to have a medium gap, and items will be aligned to the baseline. And if you're wondering what I'm doing, I'm using Emmet here to kind of auto-complete these. So that's not a feature of Hilla or the editor. It's kind of a fairly common way of building HTML or kind of helper for constructing HTML layouts. So we have a grid with 2 columns, and then in here we're going to create a couple of components. So we're going to create 2 text fields for first name and last name. We're going to create an email field for the email, and then a button for saving. So again, if we're going to do that, we're going to do Vaadin text field. We're going to have 2 of those, plus a Vaadin email field, plus a Vaadin button, like that. And then I'll add in here the label so we can tell people what to put in them. So first name, last name, email, and the button will be save. And with that, you can see we have a form here. I'm going to use a theme variant on the button to make it a little bit more apparent that it's the kind of default action here. So I'm going to say that this is the primary button, and that'll mark it. Now, what I want to do is I want to be able to select a person in the grid, have their details show up here, and then be able to update those details, save them back to the server. So let's take that in a couple of steps. So first, let's deal with selecting a person here. So I'm going to create a new method here called active item change like that, and it'll take in an event that's of type grid active item changed event of type person, because we're dealing with people in this grid. And really what I want to do is then save this newly activated person into a piece of state again. So we'll create a new piece of state that will be called selected. Selected is optional, so we may or may not have a selected person, and we use a question mark in TypeScript, similar to Kotlin, to denote that. And yes, and the type is person, of course. All right, so here we can say that this dot selected is equal to the details value, and you can see that this is of type person. So we get the event details and pull out the value from there. Now that we have the active item, we then need to kind of show it somewhere. So here in the grid, the way we do this is we have bound the items, and what we're going to do then is we're going to add a event listener, and we do that with the @ here. So we listen for the active items changed, and we bind that to this dot active items changed that we just created, and then we're going to bind the selected items like this to this dot selected. And if that works, we should be able to now click on rows and update that. And as a side effect, we now have this state here that contains the selected person. And that's something that we can use then to populate this form. For working with forms, we have this concept called a binder. And let's create a new binder here and take a look at how that works. So I have a binder, and there'll be a new binder that takes in this and a person model. Now what happens here is the binder, essentially the first this refers to the context that the form lives in, so which element it lives in. But the person model that's imported from generated code is pretty interesting. So it's essentially a more rich description of that person. So if you recall, the person interface just contained the data types. This actually contains information on all those validations that we had in our Java model. So using that model, we can now kind of create this form and reuse those same validations. The way we do that is here in our render function, so this up here essentially gives the class of the type person model. Here we want to pull up the instance. So we're going to create a constant here called model. And we're going to destructure that out of the binder like that. And once we have the model, we can use a field directive here. So we're going to use a interpolation here and type in field like that and bind to the model. And the first field, let me actually import this. So the first field will be bound to the first name, and this will be bound to the last name, and the final one will be bound to the email like this. And assuming that worked, this should actually show it, but no. All right, I obviously forgot a pretty important step here. So whenever we select the item here, we need to actually read that into the binder. So if this dot selected, so if we have a selected item, we're going to say this dot binder dot read, and we're going to read the selected person. If not, if that's not the case, then we're going to say this dot binder dot clear to just clear out the form. And hopefully that now allows us to actually see the selected people here. So now that we're able to see them, we should be able to validate that the validators work. So now if I empty a field that's required, it's not going to allow me to do that. Similarly, if I'm going to make a email field invalid, it's going to complain about that. So it's pretty cool that we're able to kind of use those same validations that we had on the server now on the client as well. And when we save back to the server, Hilla is also going to revalidate that on the way back, so we can ensure that it kind of everything went as expected. So let's implement that by going to the button here and adding a click listener. So the way we do that again is by using this @ for event listener, and we're going to bind to the click event. We're going to say this dot save, and then we're going to go up here and implement this. Save again is calling the server, so it's going to be an async method so that we are not blocking the UI as we're doing these things. So we want to keep the UI always functioning without blocking it. And what save does is it calls the endpoint and saves, but obviously we don't have a save method here in our endpoint yet, so we need to actually go there and do that first. So we're going to have a public method called save that returns a person, takes in a person that needs to get saved, and then defers that return repo save with that person like that. Yes. All right, so now we have the save method here, and what we can then do in our TypeScript code is say, first of all, get the saved return value, and then we're going to get that from awaiting this dot binder dot submit to person endpoint dot save. So we're telling the binder, essentially our form, to submit itself to the save method that takes in a person. Then if we have a saved object, we can do something about it. And what I want to do is I want to update this array of people with this updated version. So the way change detection works in lit is that it looks at the actual instance of an object that we have in our state, not at its content. So in this case, when we have an array, we can't simply just swap out the object in the existing instance of the array. We need to create a new array with that new object swapped into it. So essentially we're working with immutable data structures. So the way we, like the pattern that is used for that in TypeScript and JavaScript is to use a map. So we're going to say that this dot people is equal to this dot people dot map, and we're going to get the existing person, and then we're going to check if the existing dot ID, so the ID of the existing person is exactly the same as the saved person's ID. If so, we're going to return the saved object. If not, we're going to return the existing. So essentially, for every item in this array, except for the saved one, we're returning the existing. That way we get a new array with that one item swapped out. So if I type that correctly, we should be able to go in and change stuff here, hit save, and we can see that it got updated here. And if I go and refresh this, you'll see that it actually was persisted all the way to the database, because we're still able to see that change even though we're refreshing the browser here. All right, let's do one last little thing before we hop over to questions and answers. So I mentioned earlier that we have support for Flux endpoints, so being able to subscribe to reactive endpoints, so something that's happening kind of in an event-driven backend, and we want to be able to show those changes kind of directly in our UI without having to poll the server to see if something's happening. So for that, we're going to go again into our server endpoint. And what I'm going to do here is I'm going to create a new method that returns a flux of strings. So in this case, we're just going to do a simple string. And this is going to be called get names. So we're essentially just returning a set of names one at a time, spaced out with a couple seconds in between, so that we can see how that kind of affects the entire UI. So I'm going to return a flux of just a couple of values. So let's pick some names here. Let's do Barry. Let's do Cora. And let's do Gene. So let's pick short names. And then we're going to delay the elements by a duration of seconds 2. So 2 seconds between each element as we're returning them. So again, if we go into our UI code here, we're going to subscribe to this flux here in our connected callback. So the way this looks when we're calling a non-reactive endpoint is that we're awaiting for that one call to finish, and then we assign the value. Whereas with a flux, we know that that can return over and over again, essentially infinite amounts of times. So we can't just wait for that one thing. The way we deal with that instead is we take the endpoint, we call get names, and then we add a listener for the next value to be returned. So we'll take the return name and say this dot name is equal to that name that we got. And if we save now, we should be able to see that we have these names coming in. And because our UI is also reactive, you can see that just changing the name here actually filters down our grid. It changes the heading. It updates the text field here all in one go. So this is a way for us to build full stack reactive web apps in a very kind of straightforward way with full type safety end to end. Great. That is all I had for the coding part. Let's hop back into my slides that I was trying to show you earlier. I wanted to share you the link to the GitHub, and I'm gonna share this in the chat as well. And I think Peter's gonna share that in an email or something after this as well.
Yeah, I dropped it in the Slack channel earlier too.
Okay, cool. All right, so let's do some questions here. I'm happy to kind of hop back into the code and answer if there were any specific things you wanted to see there, or if I can explain anything better than I did. So let's open up the floor to questions. Peter, do you mind reading up questions? I'm not seeing the chat right now.
Not at all. No, no. If no one's dropped any questions yet, so we can Courtney, if we can allow people to unmute themselves, we can just jump in. I don't think the group's that large, so folks can just unmute, or you can just type it if you're feeling shy. Also, I don't know if you realize this, Marcus, but colloquially here in the Bay Area, in Oakland in particular, something is hella cool, Hella, hella cool. So I think it's just kind of funny that you named the repo. It's Hilla cool.
Oh yeah, no, it was definitely
very Bay Area appropriate. Well played.
Yeah, so Hilla is a Finnish word for a cloudberry, which kind of looks like the logo. Kind of it's kind of like a raspberry but orange, and a lot tastier. But yeah, so that's kind of what it's supposed to be. But obviously there was that's why that repo's named Hilla cool.
Nice. So yeah, folks, please don't stand on the ceremony. If you have any questions for Marcus, now is the time. And let's see. Hold on one second. Let me get the GitHub link again. There we are. Yep, and feel free to unmute and ask directly if you like. If not, Marcus, maybe drop your Twitter. Oh, there we go. Jay asking about the compare to Angular or React to Hilla.
So yeah, good question. So the kind of model that we have here is extremely similar to React. So essentially Lit and React are more or less kind of the same thing implemented differently. So Lit is a project built by Google originally. So there are the same people who are kind of pushing for these new web standards for web components. And really kind of the difference comes down to how they work behind the hood, or kind of behind the scenes. So React, as you may or may not know, uses a virtual DOM in kind of as a layer between this code that you're writing and what's actually displayed in the browser DOM. And it was using that back in the day because DOM operations tended to be very expensive, and by optimizing things in JavaScript, they were able to kind of do less DOM manipulation, and that way they could make this rendering super fast. So like you might have been looking at like, well, does it really make sense to re-render the entire like view on every keystroke? Like that doesn't seem very like performant at all. But the way these are implemented is that it's actually only kind of re-rendering those few parts that actually change. So it's a very efficient way of doing it. So the difference between Lit that we're using and React is really that Lit's based on web component standards, essentially using the underlying DOM and some new web APIs to achieve the same kind of performance and stuff, but without, or kind of with less code and less overhead, if you will. This is slightly different from Angular. Angular is a more opinionated, kind of a bigger front-end framework. So this is a model that's much more closer related to React, where you have a more simpler component model. I hope that answered the question, at least partially. Happy to dig deeper if needed.
Yeah, Jay, feel free to jump in.
Yeah, yeah,
Daniel-
and of course, like one big difference is obviously Hilla is not only the front end framework, but it also has the back end part and the communication in between. So that's a big difference between them.
That's a tectonic difference. Yeah. Yeah, absolutely. Yeah, and then Daniel asks, yeah, and by the way, the guy that asked the question, Jay, about the Angular React, he says yes, that does answer what that does answer it. So and says thank you. Daniel is curious. He says he's not sure he understood the difference between await on a single endpoint and the sort of duration on next mechanism. Is it to transfer data and allow all the reactive elements to update as that data becomes available from the back end?
Yeah. All right. Yeah. Good question. So essentially, if we look at kind of how we've implemented these two, so if we look at get names and find all, you'll see that find all returns a list of person objects. So it returns one value, whereas get names returns a flux. And that is kind of reflected here. So when we're calling find all, we say await. So just await this one value to come back and then add that to this people. Now, that same thing wouldn't work really here because when we have a flux, we don't know if it's going to return us one value or 100,000 values over the next 10 years. So the way we deal with that is we have essentially this callback method saying that anytime a new value is sent over the wire to us, here's what I want you to do with it. So it's a little different because we don't know how many times a flux will produce a value for us. And we need to be able to kind of handle anything from 0 to essentially infinite amounts of return values. And that's why we have this model here. I hope that answered the question, maybe.
Sorry, I was stuck on mute there. And yes, it does. Daniel says thanks. Yep. Yep. Yeah, and I think you're absolutely right, Marcus. I'm glad you said that because yeah, the fact that Hilla and Vaadin together sort of have a front end and a back end, right? It's a full web framework is quite a bit different, right, from React and
yeah.
And Angular, which are 100% on the front end. Now, sure. Have you been seeing things lately in the market, Next.js, stuff like that, where it's, there's sort of rudimentary backend capabilities? Yes, but that they are rudimentary in the extreme.
And also like something like Next, I also believe is more well suited for building more like a very dynamic website, whereas we're strictly trying to help build more dynamic applications. So there's also a slight difference in kind of what we're trying to optimize for.
Indeed. Yep. That's a great point. Well, this is wonderful. Thank you. Yeah, and it's really great to see that it's evolved for so much at Vaadin. This is really cool. I've seen some of the Vaadin presentations over the years, of course, at Spring One conference, and just out in the wild. And so, but I haven't seen one in a little while. So it's really cool to see this. Shahzad, hopefully I'm saying your name right, was asking if he can use, if he can use Hilla with a Node.js backend.
No, so we have specifically kind of optimized Hilla to be used on Java backends, more specifically on Spring Boot backends. So it's not to say that we wouldn't like ever explore that, but that's like our entire history and kind of where our kind of skills as a company is really kind of rooted in Java knowledge, and specifically between like this intersection of Java and the web. Like, how do we make it as easy and efficient and kind of robust as possible for Java developers to build really good web applications?
Yep. Yeah, I think once upon a time, many years ago, we were promised that Java FX would help us there, and I think I think that moment long since passed, and Google Web Toolkit is long since sort of I've stopped hearing about it for quite a many years, and I think you guys are one of the few people really out there advancing it in Java. So a lot of respect for that, and I think it's great. Folks, any other comments or questions? We've got a couple more minutes. If not, maybe Marcus, maybe drop your Twitter handle or your email, whatever you prefer. In the Zoom chat, so people know how to get in touch with you. And
Yeah, will do.
John Davis is asking about what does the future hold for Hilla and or Vaadin, I think,
Or Hilla and or Vaadin. Well, I mean, Vaadin, the kind of classic Vaadin flow framework, which allows you to build web apps fully in Java, is going strong. It's still kind of our main product. That's something that we're developing full steam ahead. And there are a lot of companies who have a lot of Java talent who really enjoy that way of building an application. They might have kind of projects where they're migrating from, say, desktop technology like Swing, and they just have a lot of skills in that area, and they really enjoy that way. The reason we created Hilla is that we see more and more companies who have a more diverse kind of developer skill set, where they have front-end devs and they have Java devs, and they need to somehow make these teams and people work productively together. And by kind of making sure that we're able to kind of move fast without kind of breaking stuff, at least without knowing that we break stuff, is something that we hope will help companies kind of build stuff further. So what's coming up next for Hilla? We're kind of listening for a lot of feedback that we're hearing from people using it to kind of understand what we need to focus on. We've heard from quite a few people that it would be really cool if Hilla also supported React on the front end in addition to Lit. So that's something that we're probably going to experiment with very shortly. I actually already have done some stuff, so hopefully we'll be posting something around that shortly. But there might be all kinds of different things when it comes to Hilla, and that's really kind of driven by people like you. If you decide to check it out and give us feedback on kind of what works, what doesn't work, like how can we make it better, and yeah.
Very cool. Thank
Anyway,
you.
yeah.
A
So
couple
let me
other
just wrap this up
questions.
let me just wrap this up real quick. So really, what I hope that kind of shown through here is that the way kind of we approached building Hilla is that we wanted to keep this as kind of simple and easy to kind of approach as possible. So we didn't really change how Spring Boot works. So if you are already familiar with Spring Boot, you're going to be very familiar with building the backend for a Hilla app. Likewise, if you've ever used React or Lit or any kind of similar component-based UI framework, you're going to have a very kind of easy way or easy time understanding how that works. So really the amount of magic we needed to add in order to make these things work more smoothly together is pretty minimal. So but at the end of the day, that little bit of magic makes a kind of a big difference in the actual end result in developer experience. So that is it. If you want to check out Hilla, follow some tutorials, find a link to our Discord or anything. If you want to chat with us, go to hilla.dev. And if you want to reach out to me after this, you can find me on Twitter at Marcus Hellburg. I'll put that in the chat as well, so you can find me there. Feel free to reach out to me anytime. Happy to answer questions. Yeah, ask me anything.
One or two others actually. Yeah, sweet. Here, hold on. Let me put your Twitter handle here for people to just click on. Twitter. Just a second. My wireless keyboard is doing some funny things today. Is it BERG or BURG?
BERG.
ERG, that's right. Okay. think I got that right. I'm really hoping I spelled it right. Let's see. Yes, awesome. Ta-da! All right, I can type. Woohoo!
Nice.
So there's Marcus's Twitter handle, just for your clicking convenience, folks. And then question from Jay. He was curious, what's the footprint of an app in terms of like running on a container?
It's a normal Spring Boot application, so
That's what I thought you were going to say.
I don't have exact like numbers for it, but essentially what you would expect from a Spring Boot application. We really don't add a whole lot on top of that.
Yeah. Yep. Yeah, I wouldn't imagine it'd be wildly different. Cool. Yeah, and so Jay, just to answer that from a more detailed, give you a little bit more detail there. Unless Spring Boot has changed, which it might have, I since I left the Spring team a few years ago, I haven't been tracking it quite as closely, but what I recall is that it defaults to Apache Tomcat, which does help itself to a fair amount of memory. So if you don't change some of those defaults or switch the underlying web server out, with a different annotation to one of the other supported ones, which I think like Jetty or Undertow, et cetera, you can be looking at, a minimum of 512 megabyte of memory, right? But that's not because like Spring is bloated or whatever. It's just, Tomcat helping itself in its default. I think the defaults are kind of a little bit more geared towards people thinking about production apps versus necessarily desktop. So, if you tune it a little bit, you can get that down quite a bit. And if I have time, I will dig out Dave Seyer's post from a few years ago on doing exactly that while we're talking. Cool. One other question. Simon was asking if is there any companies applied to production, which I think what he means to say is anyone using, do you have any customers using this in production? I think is what he means.
Yeah, we do have a couple. So the first version of Hilla came out just over half a year ago, so it's fairly recent addition. We have customers both building applications. We have a couple who are already in production, but what makes me really confident about kind of recommending this for production is that all the pieces that we've built it out of are production ready. So Spring Boot, I know a couple of people have used that in production successfully in the past. Same with Lit. That's essentially running YouTube and Photoshop online and a bunch of just like biggest things out there right now. And likewise, the Vaadin component set is something that we've used for years in the Flow framework. So all the pieces are very battle tested. So I'm pretty confident that you're going to have a good time with that. And we've had kind of good success with some of our customers already. It is you kind of missed that one slide, but it is a Apache 2 licensed open source framework. So yeah, worth mentioning.
Cool. Yep. Daniel was just about to ask if this is, open source. And then Nathan is curious if the Kotlin repo that he found in your on your page, github.com, Marcus Hellburg, he found a Hilla-Kotlin repository. So you already got a stalker there on your GitHub profile.
Yeah, good digging. Yeah, I was so we just the newest version of Hilla just came out, has a new generator that uses or it looks at bytecode instead of the actual source code for doing that type generation, which I mean, we initially did that to be able to support multi-module projects, but the very happy side benefit of that is that it also works with other JVM languages like Kotlin, which I like. So Kotlin is it's pretty cool when you're using Kotlin on the back end and TypeScript on the front end, because they share a very similar notation of, for instance, like how nullability works. So you run into a lot of kind of fewer odd kind of mismatches in how the languages think things work. So that's pretty cool. It is a very recent project that he found, so I don't think it's more than a week old, so it should be very, very up to date.